Hello guys, so let's continue from where we stopped in our lecture 4. This lecture is more like a follow-up to what we did in our lecture 4. So let's look at the polysaccharides. Now we said the polysaccharides are classified into two. Into how many? Two. We have the homo and we have the what? Heteropolysaccharide. Now we've elucidated on the homo polysaccharide in our last class, right? Now let's look at heteropolysaccharide. As the name implies, hetero means many. That is more than one, okay? More than one. It can be bi, but hetero means more than one. Now we talked about homo polysaccharide. We said homo polysaccharide. Homo means just one. Monomer, subunit. Are we getting it? Just one monomer, subunit. Okay. Hetero means many or more than one monomer subunit. So those are the two types of polysaccharide: the homo polysaccharide and the heteropolysaccharide. Now in this lecture, what we are going to look at are heteropolysaccharide. Now for instance, if we have, let's say, glucose, this is glucose, then as a follow-up, if you have, let's say, mannose, then plus you have glucose again, plus let's say this one now is now fructose. Now what you have here is a combination of different monosaccharides. Are you getting it? Combination of different monosaccharides. So that is for heteropolysaccharide. Now the next thing we are going to look at, we've talked about all this, right? We are going to look at a type under heteropolysaccharide that is called mucopolysaccharide. A kind of heteropolysaccharide that is called what? Mucopolysaccharide. Now what we have here, say the heteropolysaccharides are also called heteroglycan. They are called what? Heteroglycan. Now, talking about the mucopolysaccharide, these are heteroglycans. That is to say, they are heteropolysaccharide made up of repeating units of sugar derivative. They are made up of repeating units of sugar derivative, namely the amino sugars and the uronic acid. Now, of course, we talked about different sugar derivative. If we want to recall what we did in our last class, in our previous class, we talked about different kinds of sugar derivative. One of them we talked about are what? Sugar acid from oxidation, right? Can you still remember? The next one we talked about are sugar alcohol. Sugar alcohol. Then the next one is amino sugars. Then we talked about the oxy sugars. The oxy sugars. And then finally, we talked about vitamin C, ascorbic acid, vitamin C. So these are the types of monomers of, or let's say, monosaccharide derivative. Are you getting it? These are the monosaccharide derivatives that we looked at. The monosaccharides derivatives that we looked at. Now, having looked at all these now, what we are saying is that the heteroglycans or the mucopolysaccharides specifically, they are heteroglycans. That means they are heteropolysaccharides that are made up of repeating units of sugar derivatives. Namely, the sugar derivative we are talking about now are the amino sugars. We say amino sugars are formed when the OH group of sugar is replaced with what? Is replaced rather with NH2, which is the amino group, and the uronic acid. We talked about how uronic acids are formed from oxidation. For instance, when you oxidize the primary alcohol of glucose, it forms glucuronic acid. Are you getting it? Those uronic acid is what we are talking about. So all mucopolysaccharides consist of amino sugars and uronic acid. Now they are known as GAG. GAG means glycosamine glycan. Glycosamine glycans. And they also contain acetylated amino group, sulfate, and carboxy group. Acetylated means amino group that has what? Acetyl group attached to it. Acetyl group is something like this: CH3, then CO. So when you have something like this, you can say this acetylated amino group. Then we have the sulfate, and then finally the carboxy group. So let's look at the types. The types of or the important mucopolysaccharides we have are hyaluronic acid, chondroitin 4-sulfate, heparin, dermatan sulfate, and then the keratin sulfate. Now, one thing you should take note here is, important points to note is, one, you should be able to draw their structure. Are you getting it? You should be able to draw their structure. That is one important thing you should know. Then secondly, you should be able to you should be able to discuss their location. That means where they are found, their location in the body. That is where they are found. Is that understood? So that is what we are going to look at. Now we said all glycosamine glycan, because we say glycosamine glycans are also called mucopolysaccharides. They are also called what? Mucopolysaccharides. Now, all glycosamine glycans are of two types. They contain basically two groups, which we said consist of the amino sugars and then what? And then the uronic acid. Are you getting it? These are the two major groups that they contain. They consist of the amino sugars and the uronic acid. Okay, so let's look at the first one, hyaluronic acid. Now, where is hyaluronic acid found? It's found in ground substance of synovial joints, ground substance of synovial joints, synovial fluid rather, of joints and vitreous humor of the eye. What is the function? It acts as a lubricant and shock absorbent in joints. It acts as a lubricant and a shock absorbent in joints. Then the composition. It consists of D-glucuronic acid. Now, what you have here, from here like this down, is what is called D-glucuronic acid. Remember that we said it contains uronic acid and what? And amino sugars. And they can be acetylated too. So this one contains D-glucuronic acid. So if it is mannose that was present here, it becomes mannuronic acid. But because this one is glucose, that is this is why we call it glucouronic acid. Is that understood? So if it is fructose, let's assume it will be fructuronic acid. If there's anything like that, because let's assume it's just an assumption. So if it is galactose, it will be galactose uronic what? Acid, etc. Now, what can you see here? You see COO minus. This group here is telling you that this is an acid like COOH, but it is what? The charged form of it. So you have it as COO minus. So this is the structure of glucuronic what? Acid. Now, our numbering again. This is number 1. This is number 2, number 3, number 4, number 5, and number 6. Now, same thing here. What we have here, this is number 1, this is number 2, number 3, number 4, number 5, and number 6. Now, you discover something, that there are two linkages here that was stated. You have beta 1,3 bonds and beta 1,4 bond. Now, here's the beta 1,3 bond is. Now, this group here is what is called, firstly, let me just talk about this group here. This group here is called N-acetyl D N-glucosamine. Are you getting it? N-acetyl D-glucosamine. Because of this acetyl group here. This is the acetyl group. I told you acetyl group is something like this. CO, then CH3. Then you now have NH attached to it. That means the amino group was acetylated. According to what I told you here, that in some cases the amino group may be acetylated. That means we have acetylated amino group. So the first case here is the case where we have acetylated amino group. So this is N-acetyl, N because N is attached to the acetyl group. This acetyl group COCH3. N because N is attached to the acetyl group. So this is N-acetyl D-glucose. Normally this structure is D-glucose. Glucose amine because this is normally an amine group, NH2. But because this COCH3 was attached, one of the hydrogen left. Is understood. So just memorize this structure. You may not really want to go into the chemistry of these structures. Is understood. So that is for this particular one. We say where can we find them? Lubricant and shock absorbents in joints. Lubricant, their importance is that they act as lubricant and shock absorbent in joints. And then where can we find them? In synovial fluid of joint and the vitreous humor of the eye. So that is for hyaluronic acid. Now talking about the bonds, beta-1,3 bonds. Now here's the beta-1,3 coming from. Now you agree with me that this there is an OH here, right? That bonded with this. Now this makes this group here to be a beta glucose. Is that also? Of course, if you can see this coming here, it means that there was an OH here. So this group here as a glucosamine also is also what? Beta. So it means that the two compounds given that join together, or the two monomers that join together, which is glucuronic acid and N-acetyl D-glucosamine, are what? They are B or beta anomers. Are we getting a B anomer? But if you see this linkage, you see that it was not from number 1 and number 4 that actually linked together, but rather it was the number 1 carbon of this, which is the anomeric carbon, and the number 3 carbon of this. Look at it very well. You see that the linkage is at number 3. Are you getting it now? So number 1 carbon of this and number 3 carbon of this actually link together to form the compound. Is that understood? That was why we said this one is 1,3. Is that okay? 1,3. Now recall that we have something like N here. What is this N talking about? The N is the degree of polymerization. Degree of polymerization. N is the degree of polymerization. Now when we talk about degree of polymerization, what are we talking about? Like how many times did it actually repeat itself? Like what will repeat itself is this whole thing inside the bracket. Are you getting it? So it means that this whole stuff here will repeat itself again. So in some cases it may be like 2,000 or sometimes 20,000. Are you getting it? So it means that this whole structure here will repeat itself 20,000 times to give what? Just the hyaluronic acid. Is that understood? Now, the inner monomers are linked by beta-1,4 bonds. However, this group here that you see here is linked to another of this group with what I am saying is, you see this whole structure here from here down, then down here like this. This glucuronic acid is linked to this N-acetyl glucosamine with a 1,3 glycosidic linkage. That is what we have here. And then this whole thing, like I told you, that this whole thing will repeat itself thousands of times. Are you getting it now? Thousands of times. And see the ending here. Are you getting it? This ending here is what? At the 4th position. Why this ending here is at the 1st position. So it's more like, if I want to use a structure to illustrate, let's illustrate here. It's more like glucuronic acid. What you have here, let's say this is glucuronic acid, right? Let's say this is glucuronic acid. The ending of glucuronic acid here is what? 4th position. Is that not so? Why the ending of N-acetyl glucosamine is what? The 1st position here. Is that understood? So it's that this one is 4 to 1. it means that this whole structure here is just one unit, which is a combination of glucuronic acid and N-acetylglucosamine. So it means that if I want to add more of this one into like 10,000 times or 1,000 times, it means that I will be adding 4 to 1, 4 to 1, 4 to 1 like that. So it means that we will now have another structure. What are we having here? Here will now be what? 4. Here will be what? 1. Because we say this structure will repeat itself over and over again. So here will be what? 4. Here will be what? 1. Now, what can you see here? These two structures must join together. True or false? It means that for these two structures to join together, what bond join them is 1 and 4. Remember that this is beta glucuronic acid and this is beta N-acetyl D-glucosamine, right? So the bond that will link each of the units together, are you hearing it? Is what is called the 1,4 bond. Beta 1,4 bond. Is what is called the what? Beta 1,4 bond. Is that understood now? So the two bonds you are seeing here, 1,3 is talking about the two monomers that forms the unit. Two monomers formed one unit. Are you getting it? Two monomers formed one unit. Two monomers to form what? One unit. Now, let's say 1,000 of the units will form hyaluronic acid. So the two monomers form one unit. The unit will repeat itself over and over again to form hyaluronic acid. And the bond that link them together, that links each of the individual units together, is 1 and what? 4. Is that understood? So that is that for hyaluronic acid. Now, the next one is chondroitin sulfate. The pronunciation seems so awkward. Chondroitin sulfate. Now, where can you find it? You can find it in mammalian tissues like the bone, the cartilage, the tendons, the heart valves. You can find it in bones, cartilage, tendons, heart valves, skin. Then you can also find it in cornea, the cornea of the eye, where images are formed. Are you getting it now? You can find chondroitin sulfates there. Is that understood? So this is the composition. It composes of D-glucuronic acid. Now, of course, we know that this is D-glucuronic acid, right? This D-glucuronic acid. Glucuronic acid. And then N-acetyl galactosamine phosphate. Galactosamine phosphate. Samine phosphate. Now, everything I explained before is still the same thing that we have here. The structures are similar, just a little modification in one or two of the atoms present. Are we getting it now? So this is also 1 to 3. You know why? Because this is position number 3 and this is what? 1. Okay? Then this one has sulfate at position number 4. That was why we say is galactosamine phosphate. Now remember that this is not structure of glucose, but what? Galactose. The one we did initially was glucosamine. Are we getting it now? This one is galactosamine. N-acetyl. You know why? This N and this is what? Sorry about that. This N and this is what? Acetyl group attached to it. Is that understood? So that is for this. You know why it is 1 and 3. Everybody know. And the reason why it is 1 and 4. We say N here is the degree of polymerization. Okay? Degree of polymerization. So that is everything basically you need to know about chondroitin sulfate. Most especially where it is found, mammalian tissues like the bone, the cartilage, the tendons, the heart valve, the skin, and the cornea. Composition: D-glucuronic acid and N-acetyl galactosamine phosphate. The linkage is 1 to 3 bonds for the monomers that make up of the units, and then 1 to 4 bonds for the units that makes up the chondroitin sulfate, which is the polymer itself. Now the next one is dermatan sulfate. Now dermatan sulfate, you can find it in heart valve, blood vessel valves like the artery, the veins, etc. You can find it in heart valves, and you can also find it in skin. When you have the word dermatology, just know skin, dermatan sulfate, skin. Now, what is the difference between dermatan sulfate and this chondroitin sulfate. If I were you, I would just memorize these two structures. Know that you are changing just one thing in them. Now, chondroitin sulfate and this, the only difference is the uronic acid. Remember that what we had here was glucuronic acid, right? What we had here was D-glucuronic acid. Now, here what we had was L-induronic acid. L what? Induronic acid. Now, how did this come about? By just changing the position of H and what? COO minus. Remember that this case, the COO minus is on top. What you do is bring it down for the case of, for this other case here, which is demantan sulfate. So chondroitin sulfate and demantan sulfate are almost the same. The only difference is this carboxylic group here is brought down, and this OH group is, and this hydrogen group is what? Taken up. Is that understood? That is differences between them. So if you are able to draw the structure of chondroitin sulfate, you should be able to draw the structure of demantan sulfate. Okay, demantan sulfate is found in heart valves, blood vessel valves, skin especially. This one is very easy. What is the importance? It helps to maintain the shapes of the tissues. Shapes of the tissue. The bonds, everyone knows what the bonds are. 1,3 bonds and then 1,4. The N is the degree of polymerization. When you talk about degree of polymerization, I said, to what extent do they link together? The degree of polymerization may be 50. Let's just say 50 of these join together. Are you getting it? Consecutively. It may be 1,000. Like, let's say 1,000 of these join together, and so on and so forth. Okay? So that is for demantan sulfate. The next one is heparin. Heparin, you can find it in blood, liver, kidney, spleen. Anything that has to do with blood, that has blood in it, you can find heparin there. Why? Because it acts as an anticoagulant in blood. Heparin acts as an anticoagulant in blood. You may be asked, which of the following carbohydrate acts as an anticoagulant in blood? The correct answer is what? Heparin. Correct answer is heparin. Now, if they ask which of them helps in GFR, glomerular filtration rate, you should be able to provide the answer to that. Okay. Now, the composition of heparin is N-sulfoglucosamine 6-sulfate, N-sulfo-D-glucosamine 6-sulfate, and glucuronate 2-sulfate. Glucuronate 2-sulfate. If you want to memorize, you can memorize. As for me and my family, I have chosen my course. Okay. But this is the composition: N-sulfoglucosamine 6-sulfate and glucuronate 2-sulfate. The bond that link them is still B13 bonds, and no. This linkage is wrong. The linkage is wrong. What we have here is 1 to 4 linkage only. Are you getting it? What we have here is just 1 to 4 linkage only, and it's not even beta, but rather it is alpha 1 to 4 linkage. Okay, so this is alpha 1 to 4 linkage. It acts as an anticoagulant. Okay, so that is for heparin, and I believe this is the last one for carbohydrate lecture. Keratin sulfate is found in cartilage, cornea, and connective tissues. Which of them did we say is found in cornea and connective tissues again? Chondroitin sulfate and hyaluronic acid. Okay, hyaluronic acid is found in vitreous humor of the eye. So that should be chondroitin sulfate and I think just chondroitin sulfate, and then now we are having keratin sulfate. Now, keratin sulfate comprises of D-galactose and N-acetylglucosamine 6-phosphate. D-galactose and N-acetylglucosamine 6-phosphate. This is wrong. Just little omissions. Okay, that linkage is wrong. The linkage is, although is beta, right? But it's beta 1,4 linkage. With you just looking at it, you should be able to predict now. this beta 1,4 linkage. Okay, beta 1,4 linkage. So that, yeah, beta 1,4 linkage from here to here, 1,4. This beta, this 1, and here is what, 4. Beta 1,4. This is also beta, right? Beta 1,4 linkage. We said it can be found in cartilage, the cornea, and connective tissue. Now, what you may be given in the exam, they will just say draw the structure of any of them, 2, at least 2, and then state where they are found. That is just it. So at least you should be able to draw structure of, let's say, all of them if possible. We are aiming for the best. We are aiming for 5 points this semester, and I want to work with as many of you as possible that really wants to actually succeed in this level. It's not easy, I bet you. It's not going to be easy, but we are going to scale through. Are you getting me? So that is that for carbohydrates. So carbohydrate is a wrap. Okay, we'll take our quiz tomorrow by 4 p.m. Carbohydrate is a wrap. Love you all. And then for those of you that wants to get iPhones, or you want to make your uniform, you can contact me to make your uniform, both pharmacy and other CHS courses. Also, if you want to do your course enrollment, you can also call me. Or you want to pay your school fees and then hostel accommodation, then school fees payment, also you can message me. Thank you very much for your time and for your patience. We live to see in protein again. Bye bye.